problem is ridiculous, but it has every property we could ever hope and dream for. Look at all this. This is bonkers. But it's all stuff we can do. It just looks overwhelming. So look at the numerator. We're multiplying these radicals. So I have 40 times 6. 4 times 6 is 24. So 40 times 6 would be 240. Now when we multiply variables with exponents, remember we add the exponents. So a to the 9th, there are no other a's, so it's just a to the 9th. For the b's, we got b to the 4th times b to the 9th. 4 plus 9 is 13. For the c's, we have c to the 3rd times c to the negative 2nd. We add 3 plus negative 2, we get 1. You could write the 1, you don't need to. For d, we have d to the 1st over here, and we have d to the 5th over here. 1 plus 5 would be d to the 6th. For e's, we only have e to the 11th, and then we got the f to the 12th. So this is the numerator. Denominator, nothing to combine there. 200 a to the 35th, b to the 13th, c to the 3rd, d to the 9th, e to the 1st, which is just e. Now anything to the 0 power, just clear it out. You could write it initially, but anything to the 0 power is 1, so that's gone. So now just looking at the red stuff here, let's simplify what we can. Remember, we can simplify the 240 and the 200. They're both divisible by 10, which would make it 24 and 20. And then you're like, well, what goes into 24 and 20? 4. So 4 goes into 24 6 times. 4 goes into 20 5 times. So let me rewrite our new radical here. So far we have a 6 up top. We have a 5 down in the denominator. Now when you divide with exponents, you subtract the exponents. And you always put them where there are more. So if you look at the a's, I have a to the 9th up top. I have a to the 35th in the denominator. So you can do 9 minus 35 and get negative 26. But remember, you can't have negative exponents, so you would then put it in the bottom. Or you could just say, there are 26 more in the denominator. So that's where they're going to end up, a to the 26th. Now for b's, we have 13 up top, 13 on the bottom. They just cancel each other out. The c's, we have c to the 3rd in the denominator. We have c to the 1st up top. So there are 2 more c's in the denominator. Those are handled. We have d to the 6th over d to the 9th. So there are 3 more in the denominator. Those are handled. E to the 11th over e to the 1st. There are 10 more e's up top. And we have the f to the 12th up top. Okay, we're still good. So as far as perfect squares go, remember, we can't have radicals in the denominator. So that 5 can't be down there. We're going to have to clear that 5. The way we can do that is just multiply by root 5. The a to the 26th, it's even. It's perfect. We don't need to change it. Same with c to the 2nd. Now d to the 3rd, that's a problem. We need an even exponent on the d. So we can just multiply by d to the 1st, and then it'll be even. All right, let's clean up what we can. So up top, 6 times 5 is 30. We have d to the 1st, we have e to the 10th, and we have f to the 12th. Denominator, 5 times 5 is 25. We have a to the 26th. We have c to the 2nd. And now we have d to the 4th. I'm going to start the next video to finish this one up. That's bonkers.